Cool. So those of you who are going into physics, or maybe have had a little bit of physics, you see this whole idea of initial and final. Initial position, final position. Obviously, you always do final minus initial to see how much it really changed. So if I just reverse those two, it's going to be the negative of what it was before. Right? Okay. All right. So let's do this. How do I add two vectors? Good scale this in a minute. So if I have a vector, say this is a vector, so I get all 3, 4. And then I have a vector (1, -5). So we see U would be 3, 4. V would be 1, -5. Cool. What's your gut tell you would be what you would hope would happen? Just add them directly, right? And if you think about it, if I'm pushing on something, I can't move it, and somebody wants to come help me, they're going to push in the same direction I'm pushing, obviously. Then we want to move it that way. They're not going to push somebody, they're going, I'll help you. You know, I'm pushing this car, and they're like, I'll help you out. Right? So I want the pieces that are in the same direction to add up. That's what should happen. So how much? If this is me, I'm pushing this way, and somebody else comes and pushes it that way just to be a dork about it. So this is me, this is Jeff, this is them, whoever they are. We'll just call them dork. Which part of me, could you draw it on there? The part of my vector that is acting in the x direction. It obviously would be the x piece of the vector name, right? It would be the 3. And which part of him is acting in the x direction? The 1. So in the x direction, if this is a force, if this is how strong we're pushing, how strong are we pushing in the x direction? 4. 1 plus 3, 4. Cool. So it is exactly what you would think. You just add it straight down. So U plus V is 4, -1. Now you can kind of see the -1 because I'm pushing, my upward force is 4, which his downward force is 5. So he kind of beats me out by 1. So we end up going down 1. All right, cool. How are we doing so far? Thank God that works that way, right? And it works that way for whatever dimensions you want to do. Because you can break every vector down. If you have 5 dimensions, then you have 5 axes somehow. Which if you're going into physics, you'll have n dimensions, however many dimensions you want to work with. So that means you have like an x-axis, a y-axis, a z-axis, an a-axis, or whatever the hell axis, right? And you can break it down along each axis and just add up those pieces. You just have to add the pieces up, thank God. Well, another way to look at this to make it make a little more sense, maybe. Well, that's pretty easy, but just to show you physically a little more sense. If I think of this as a displacement, so I'm walking along in a neighborhood, and this is the whole idea. If I walk this way, and then I go, oh crap, I walk that way. What's my true displacement then? How far did it actually go? So if I go this way, U, and then from here I go that way, V. When I add them, I'm going to get this vector there, which would be the 4, -1. So that's the whole idea of what they would call parallelogram method. Because what I really made here were the diagonal of this parallelogram here. You guys see that? It's really more direct. You can just think of it as a triangle where you just connect the sides there. To find how long it is, it really is just add the components. But that's physically what's going on. A displacement vector here, displacing it this way. So overall, how did it displace it? That much. Sweet. And they call it the tail of the head. You draw 1, and you put the tail of 1 there on the head, and see where it ends up at the end. Does it matter then what order I do this in? Of course not. Therefore, it's what? What's the name of that property from a million years ago? Not associative. Associative is parentheses. Commutative. The reason I want to say that is, how many of you guys are math majors? A few of you guys. How many of you guys even have a clue how close you are to earning a math major? A few of you guys. You should look at it, because if you're doing a different major but you're really close to doing a math major, you might as well declare for that bad boy, right? Or if you're just going to transfer, you're not going to get a major, you might be like one class away from getting an associate's in math. You never know. So you should check it out. My point was, I'm trying to stall for time because I forgot my point. Oh, thank you. If you go further in mathematics, you start talking about very abstract ideas, where you go outside our entire number system. Our number system is commutative in certain operations, associative in certain operations. This, what we're setting up, the vector system, seems to be commutative over addition. We basically almost proved that, because I could go v and then u, and it's the same damn place. So I don't really need to prove the damn thing. There it is. I mean, of course I'm going to end up the same place. So u plus v equals v plus u. It's pretty given. So that would be commutative. So those words are going to come back in, and they're going to have a lot more meaning. I almost hate teaching that to algebra students, because at that level it's just really saying you can add whatever order you want to. That's what commutative and associative laws say about addition. You can add whatever. They say the same thing. Okay. They go off on more tangents. What about subtraction? So again, if I have my u is 3, 4. What if I were trying to subtract something from this? So if I have another vector, let's do the same vector. V was, so V is 1, -5. What would u minus v? Now, in one sense, that's also damning, because what is subtraction? It's just the adding the negative, right? So one thing that now we need to talk about is, what does it mean to multiply a vector by something? So a little side discussion. Because I'd like to be able to apply what we just did a second ago, but we know how addition works. Well, u minus v is the same thing as u plus negative v. We kind of know what the hell that is. We hope to God it's what makes sense. What do you think negative v would be? Thank God that's what it is, right? Obviously, if I have, and it's exactly like this. If I'm pushing on something, and I'm like, this thing's not moving, and I push on it with twice as much force. So if my u was 3, 4, if I push on it twice as much force, now it's going to be 6, 8. Of course, because if I'm applying twice as much force, I'm applying twice as much in this way and twice as much in that way. Twice as much total, right? So it does exactly what I want it to do. Scalar multiplication. I don't think I've said this word yet. Anybody know what scalar refers to? Beautiful, right? Vectors have length and direction, magnitude and direction. Numbers are just scalars. They don't have any direction. So a good example physically is, if I'm in a car, I can say I'm going 10 miles an hour. It doesn't matter if I'm going that way or that way or that way. That's 10 miles an hour. Doesn't care what direction. Or if I'm going this way 10 miles an hour and then I stop and I start backing up at 10 miles an hour, that's -10 now if I want to talk about vectors. Because that would be the direction. Cool. So scalar multiplication, c times u would just be c x, c y, c plus, however big u is, right? For us, we're only talking about 2 dimensions right now. So negative v is just -1,5. You just add the damn things together. Okay? So to finish that out, if I have this, it would be 3, 4 plus -1,5. So it would be 2, 9. Right? And you really don't have to do this now. You really don't have to do that, obviously. You can just leave it as minus and just subtract the components. Not a big deal. Right? Sort of like distributing that negative. Okay, cool. So one last thing I want to talk about is the physical interpretation, the visual interpretation of that minus, and then we'll call it an early date, if that's all right. I normally don't get too much disagreement with that. So really the whole head to tail thing, we could go that way. But what I really like to look at is truly, what should u minus v be? What does subtraction tell you in general? When I do 10 minus 3, if I'm 10 years old and somebody's 3 years old, it tells me how far apart we are in age, right? The difference in age is really how far apart in age. If I told you, can you draw a line that shows me how far apart u and v are, where would that line go? Yeah, it would go here. Now we're going to talk about direction in a minute. I'm not going to put the arrow there yet, because the direction is a whole other thing. So if I want to know what u minus v is, that's what it is. That's at least the length. Now we've got to figure out the direction real quick. And if you think about it, here's my v. There's my u. Shouldn't v plus this equal that? You guys see that? Shouldn't v plus the u minus v equal this? Okay, so which direction should this point then? Up. So let me show you, there might be a better picture in here. Page 683. So on page 683, right on the very first couple pictures there, they have the triangle rule. But personally, I just like to remember, it just makes more sense. It's the distance between them, which is right there. It's just which direction it's going to point. It's always going to point in the direction of, so it's going to point up here, right? V plus this equals u. So just like I have here, it's always going to point in the direction of the first guy, u minus v. First guy's u, so it's going to point in that direction. Cool. And in fact, does that make sense with what we got mathematically? With what we got this way? Because if I pick this up and put it at the origin, pick it up, put it here, it's going to point at the point 2, 9. Makes sense, right? So this is a lot of times in mathematics you're told by your teachers that there's a lot of different ways to do proofs, to do problems. You can do it visually, you can do it algebraically. You've seen some of that in algebra a million years ago. This to me is one of the clearest examples of, there's the math of it. You can double check it with the visual of it to make sure that it makes sense. Because the answer you got here makes sense with the visual. And it totally does. Thank God. It's my hope. Alright. So, just to remind you guys, if any of you are at all interested in the MyMathLab possibility, did I say I set up one of those? Yeah. I did set up like a MyMathLab shell. If you want to do any of that stuff online, email me. If you need a syllabus, go to the website. I'll see you guys Wednesday. Next I'm going to bring the anchors. I just didn't